Today we're going to do a walkthrough of the Whodunnit case from Road to Las Vegas 2. We have with us Harry Watson.
Good evening, Jaq.
We'll have Elliott doing a walkthrough of your case. Why did you create Whodunnit? What was the inspiration?
One of the earliest sort of pet projects I did in Excel, probably when I was 13, 14, was to look at cryptography, just if I could get a simple shift into Excel. And then from there, that evolved into things like looking at the position as well as the content of each letter. And I thought, this is fun, and I know more about this. And I've written a few cases which seem to have been quite popular, and I could make this one quite complicated if I wanted to. Let's try it out, but with Unicode characters, just to make things really interesting and a bit different. To have a scary screen full of Unicode characters that no one understands.
You're decoding some messages. Some criminals have learned to code in Excel state. You've got Caesar shift, a cipher, and then you've also got an long shift, which varies throughout the string in the later questions.
This means you then have to consider where you are in the string as well as what the string is in order to crack the code.
Question 1 and 2.
It's just to get you familiar with the functions. Every character that you have on your keyboard that you type in, and many, many more that you see written around, have a code.
Yep.
And there are sort of two different ways of doing this. One of them is ASCII, which contains 128 characters in earlier versions, 256 and later. Then you have Unicode, which has a far broader range of characters.
Yes.
Which you can. The easiest way to access in Excel is by sort of typing in the code and then saying equals Unicode.
There we go. Like Harry said, we're going to be using code for anything that's not a number already, and char for anything that is a number. That's going to give us some errors at the moment, and then we can combine those two. So we can make this answer say if is number. We can use this to test whether or not this is already a number. If it is, then we're going to take from this column. Otherwise, we're going to take from that column. Very similarly, for level 2, like Harry was saying, that's going to be extended using the Unicode and Unicar. These characters are not giving the right to Unicar, the right code if you use code, because they come from that extended character set. So just going to turn both of these to the Uni versions, pull that on down, and then we can use the same logic that we used before to get level 2 done. Back to you, Harry and Jaq.
Level 3 and 4.
Level 4 was my level 1.
Level 3 introduces the idea of applying a shift. It's not going around the alphabet more than once. So you don't have to use a mod function.
That's a really interesting point there from Jaq. So I did use the mod function when I did this originally, but I think she's right that we don't actually need the mod function because we're not having any wraparounds that are more than 25 or more than 26 over. First, we're going to grab the Unicode of this character here, and we're going to add on to that the shift that we got from the question. We're going to use the fact that the Unicode of A is 65 and the Unicode of Z is 90. And like Jaq said, we can simply say if this is less than 65, then we're going to add 26 to it. Otherwise, if that is more than 90, then we're going to subtract 26 from it. Otherwise, we're just going to take that number. Using Unichar, we're going to turn that back into the character. That is a lot easier than what I did. Like I said, I did use mod, like Jaq was talking about in her segment. But yeah, I think that is an easier logic. You don't have to deal with the mod and the wraparound quite so much. And similarly, we've got the same thing here. So we need to split out this text. A lot of the time when people are splitting out text, they will do the mid of that text, starting at, and then use sequence and use the length of, let's do it in the columns, the length of that text to split it out one character at a time. Now that does work, it's a little bit old-fashioned. I like to use regex, which is a lot newer, because in regex, even if you don't know regex, you can learn this nice and easy. You take the text that you want and then the pattern you want is simply one full stop, a period if you're in the States or some other countries, and then we'll use return mode of 1 to get all the characters, which is just like we did there. We will then do the same logic we did here. The longest one of these is max len of these words, 11. Right, so we are going to say sequence 11. That's going to tell us where this needs to go. We're going to do the same thing there. And essentially, we're just cheating this a little bit so that we don't have to do anything fancy and simplify out our logic into a single cell. There we go. And then our answer will always be in that column. Now, if we pull this down, there we go. And we can see those do look like words. They even look like Excel words. So those are probably the correct answers. There we go. That was level 4 and level 3. Back to you before we jump into some of these levels which start to get a little bit tricky a little bit quickly.
In level 5, using the same shift that I was using in level 4 on a single word, but it's extending it to a whole string. And the only difference now is they don't tell you how much it's shifted by.
Yes, they don't tell you how much it's shifted by, but a clue is given to help you work that out. Yes. Or to work out what the possibilities might be.
That is where you start getting inventive with your solutions.
There we go. Jaq is promising that I'm going to get a little bit inventive use. I'm not quite sure that that's true. So what we need to do here is to work out what the shift is and use that to work out what the last word of the sentence is. So first of all, let's get the last word of the sentence, because that is going to be important. And we want the last one. There we go. That's the last word of the sentence, which is a great place to start. We need to work out what this shift is. We can see here some days of the week, and we can see in the instructions that each of them start with the day of the week. So let's do the same thing and get text before, in this case, the first word, and this is last word and day of week. Now we know, in fact, we know that this is going to say day on the end of it, so we want the last 3 characters. We don't even need the last 3 characters, we just need the last character, because that is always going to be a Y. Okay. So that is our Y. So if we find the Unicode of this, and we take that away from the Unicode of Y, we will get what the shift is. Let's use regex to split out as we did before. This time I am going to try and do it all in one place. So we're going to use Unicode just like we did before. We're then going to add on our shift. Now we need to do our if thing, our switch statement. It's not a switch statement because they're comparators. So we want to say if this thing that we're looking at is less than the Unicode for A, then we want this thing plus 26. Otherwise, if it is more than the Unicode for Z, we want this take away 26. Otherwise, we just want this. There are the new codes after we've shifted them. We then wrap the whole thing in a unique char this time to turn them back into letters. We are going to concat that result. Excellent. Hopefully these remain as words as we go down, and we have cat, week, holiday, floor, Friday, battle, happens, papas, world, appointment, summif, etc, etc, etc. Now I think Jaq might have something to say about these entire sentences, because when you translate those sentences, they are quite interesting.
The 18th of August one was one of them.
The example was that the 18th of August is a great day to write a case.
So I wrote this case over about a month. I started in August, finished in September.
It almost feels like you're talking us through your life at that point in time, because then you mentioned Monday the 26th of August is a UK public holiday. Thursday is a great day for an Excel battle. And then we get to a dentist appointment on Wednesday the 1st.
I had a dentist appointment in September. I don't think it was on the 1st, though.
Monday, December 2nd is a good day to visit Las Vegas.
That's good. That was in there.
Tuesday 20th, practice some if. If you were thinking well ahead and you knew that you had a case coming out in May the next year.
Not a conspiracy.
Confirmed this is not a conspiracy.
It's a nice one as well to decrypt, because you've got the at a day repeated twice. So really you have no excuse for not, because it's not a word that's necessarily in the vernacular of everyone, but
In level 6,
it's slightly more mechanical in the sense that in that case you're encoding as opposed to decoding.
we have a list of people. We have a sender and a recipient. They have a number of shifts between them with a very evil mode cell in the top left.
It wasn't actually intentional. I wasn't planning to be evil. I mean, if some people thought that was evil, that can only be a good thing. And I mean, it's character building, if nothing else.
Okay, for this we need to do a couple of bits of setup. The first is to get our senders and recipients matrix. So I'm going to say we're going to have the sender names and then the recipient names. And we're going to take this and we're going to use tocol to make this a 1D array. We're going to do the same thing on our codes here. And we're going to have the sender and the receive. Let's go with recipient because I don't know how to spell receiver. Recipient. And it's going to be the text before of this and the text after of this. So that will be useful in a moment because we're going to need that to work out what our ordinary shift is.
That is the starting shift amount. It then introduces the along shift.
Originally, the along shift and the Unicode concept weren't introduced in the same level.
And then we've also got this along shift to deal with. The along shift does things a little bit differently. The first character in a sentence or a string is indexed at 0. The second one is indexed at 1, at 2, at 3, and 4, and so on. That is your position within the string. You then apply the along shift that many times based on the position. So the first one's always going to be shifted 0. And then if it's a Monday, they're all shifted 0. Nice and easy. But if it's a Thursday, everything is going to be shifted by a multiple of 3. So the first one will be 3, second will be 6, 9, 12, and so on. Let's have a go at using this then. First of all, we're just going to look up the day of the week to get our along shift, making sure we lock our references. So that's our along shift. And then our ordinary shift is going to be got by an XLOOKUP of this, the sender with a dash, and the recipient. Now that I think about it, I didn't need to split these out, but I think that will become useful in a later level. And we're going to return our codes, making sure, again, that we lock things we need to lock. So there are our ordinary codes. That is everything that we need now, because all we need to do now, we don't need to worry about the wraparound. We're creating weird symbols. So we're going to regex extract just like we did before, using our simple full stop and our 1 to get all of those characters out. We're going to get the Unicode of those characters. And the first thing we're going to do is we're going to add that ordinary shift. Now for this along shift, we're going to need a sequence that goes up. So we're going to need a sequence that is the same number of numbers along the columns. So let's put in a blank argument for the first one as our first word. And we're going to start from 0 and we're going to step by our along shift. So 0, 2, 4, and so on. So I'm going to grab this for now. There we go. Take it out of there. And we're going to add this on like that. Then we're going to take the whole thing, going to unicar it back, and we're going to concat it back. So we get a single word, which hopefully is the answer we are looking for. There we go. That is level 6 done back over to Jaq and Harry to see if they can give me a little bit of help with that final level.
And then it finalizes with level 7. I'm not gonna lie, I still have not done level 7. Can you maybe describe what's happening in this one?
Okay.
Because,
So level 7 now, we have some people who have confessed to some very heinous crimes. Someone's committed octahex, for instance, which is one of the most egregious things you can do in Excel state. These confessions, which are in code, can be found on the correspondence tab. Looking at the people tab, they've been written by a sender and sent by a receiver, but you don't know which ones they are. Depending on the day of the week, there's also a long shift applied, but you don't know what that is either. What you do know, the one thing that has been very kindly given to you, is that each piece of correspondence starts with the day of the week. Just the first letter, for instance, you can work out what the possibilities are.
there's a space that's included. You haven't shifted the space. So you can see that the first word is always going to be a day.
And you know that in columns H, I, and J, you've got D, A, Y there.
I've extracted the characters from the first example. Sorry, not the first example, the first row of correspondence. And extracted the letters, and you can see that my column K is a space, which means that the 3 columns before that are the letters D, A, and Y. So if we had the Unicode of these, so we know the difference from D to A is -3, right? So if you have this, that, minus that, what we would expect from D is to have equals that -3 plus whatever the shift is. So the shift would be equals that minus that. So we know that the shift is 4, which would suggest it's a Friday. That suggests that those letters are Friday. And then from there, you can work out that this is going to be 0, 4, 8, 12, 16. I'm doing this very manual at the moment, by the way. Code of F will be your 70 equals that minus your 70. And you've got 10, 5, 5, 6.
Now you can see who sent the code.
I can see that Felix sent the code to Benjamin. Is that the correct answer? Did Felix octahex? Or did
Felix committed the crime that's in the first row of the correspondence tab, but you still don't know what that crime is.
Oh, right. Yes, okay, you've got a list of crimes here. That's not on a row by row on the matches, is it?
No.
God damn it.
That would be too easy.
Okay, I think I've followed your logic along there, Jaq. Let's see if I can pick up where you left off and finish solving this. So we now know that it was Felix that did this. So we know the ordinary shift and we know the long shift. Where do we go from here? So now we need to translate the whole sentence. So we can use regex extract on our sentence like this. And I think I'm going to have to turn this into a data table in a minute. So I'm going to make this be that one there. So that's the message. And we're going to make this one point to there. And we're going to make this one point to there also. And now we'll be able to use a data table when we finish this. So there are all of our characters shifted out. We're going to need a sequence that is the number of columns as the length of this word, this sentence. And we're going to start at 0 and we're going to step in our long shift. We're going to get the Unicode, all of these. And we want our ordinary shift, which we've already got. So we're going to do this, take away, we're going to do this, take away our long shifts, take away our ordinary shift, and hopefully be left with car on this, like that. That's going to give us some errors on the spaces. I think it's also going to give us errors on numbers. I think this one here, the 2, is going to give us a value error, but that's not a problem. We will need to solve for that in a minute. But then our final answer is going to be concat of if error of this space. Friday, I committed oct space hex. Now we know from the question that oct to hex is one of the things we're looking for. But that's fine because we can then sort that in a minute. So that is going to be the answer to, that is going to be our answer to our data table. Our inputs are going to be these here. And then we're going to use one of the great tricks of competitive Excel, which is these data tables. I had never heard of these. They can be a little bit confusing. It's worth checking out a video on how to do them. But basically, we're going to put into this cell here each of these columns. That's from our column input cell. We're going to change it to each of those in turn. This very often happens. It's to do with the automatic calculations. If we turn things to automatic, we will now get our translations there. So where do we go from here? Well, we're going to need our words here, but we also know that we need to replace anything that's a number with a space. Now there's only two with numbers here, so we can do this manually. I'm just going to copy all of these across to here, and on these two I'm going to replace that number 2 with a space. And now we should be able to say, I think we could even use XLOOKUP with our lookup value, looking up in this array here and returning from this array here, making sure we lock those. And we can use the fact that we now have a match mode of regex to return. That's not quite what I wanted to return, that's the message it's in. That's fine though. What I actually want then is I want this, and then I also want to do a second data table, the humanity, which just looks at what that person's name is, what that sender's name is, and those two things together I think are going to give us what we need. So back to data table, our input cell was this one here. That should give us a list of senders. And now instead of looking this up and returning that column there, we are instead going to return the sender of the message, making sure we lock that in. There is Rachel, as in the example. And there we go. As we know, Felix did octahex. And there are our solutions. Thank you, Jaq, for building out the beginning of that. I couldn't have done that quite so easily without following through your logic. You definitely did the hard bit there, and I could swoop in and play the hero, finishing that off. So thank you for that, and back to you guys in the studio.
That's a hell of a lot in a level 7. How much worse is your level 7?
Oh, it's much worse. We're going to be doing this this speed run, and the more clues I give away, that's bad for you because it gives Dim a hint.
Stop watching this. You shouldn't be on here, Dim. Go away. There were one or two other things that popped up. There's some controversy, some hype, that kind of thing.
Oh, yes, the controversy and the hype. Something published a few days before about do these Unicode characters work on your computer?
So there was a lot of conversation that initially came up because of this, and people had theories about what your case was going to be about.
I didn't see it until probably a day after everyone else did. I was a little bit scared. Luckily, no one got that close.
The interesting thing about the few days before the case, FMWC themselves, when sending out this Unicode file, actually sent out a named range hidden in the Unicode file.
Yes, which really scared me because I couldn't see what was in the file. And when people were making sarcastic comments about it being really useful, I thought it might actually be useful and think, oh no, they're making my case easier. This is bad.
As it turned out, this named range was called Nothing to See Here. I think eventually someone did drop it into the WhatsApp chat to kind of like set everyone else's mind at ease. It basically was just a lambda saying, you know, if this is 0, say you don't need any more clues or something along those lines.
You don't need any more hints, I think.
You don't, and then the alternative was stop looking for hints.
The distraction that all of this is causing, the financial modelling world is going to be on its knees soon.
The other aspect was, in one of your original levels, which is the level 6, the words used as the input clue, if you read top down, it says for bonus 4 and 5, you should look to column B at what word the questions start with. Heed this clue.
Not a clue, wasn't a clue in the first draft either. Hopefully didn't waste anyone's time, apart from all the people whose time it wasted, in which case, but probably shouldn't be looking for clues and just...
So what we've learned from Road to Las Vegas 2, from Whodunnit, is if you are given clues, they are probably completely meaningless, and stop looking for the clues.
Well, if it provokes conversation afterwards, that can only be a good thing. I always enjoy that. It's always fun to see people receive things. I put jokes into these cases to amuse myself, and then completely forget about them by the time they go out. So they go, oh, they've noticed that. I completely forgot I put that in there. With sensors as well, when I put in the units of measurements and I included the smoot after George Smoot, and people picked up on that, and oh yes, of course, I put the smoot in as well. I feel like being a case designer is a very good opportunity to sort of put character into them and make these jokes as well, because they sort of carry throughout the community, and it's just a nice thing to see and a nice thing to do.
Yeah. Is there anything further you're keen to say to our UK contestants who will be watching this?
To our UK contestants, well, if you're watching this, then yes, please do come along, and you have as much chance as anyone else as beating people and becoming the UK champion. We're going to be releasing lots of free cases this year. There really is no excuse not to get involved. It's going to be a lot of fun. If you enjoy the likes of Whodunnit and other Road to Las Vegas cases or our free cases, there's more to come. And of course, if you wish to go on the wild side and go to Sin City itself for the sin of 3 days of Microsoft Excel, which is the greatest excess you'll experience in a year, you must do this. There's nothing else you ought to be doing in the first week of December.
Yeah.
I think it's apparently meant to be the world's largest atrium.
That's unsurprising. It is big.
If you like big atria and you like Excel, then you know what you need to be doing in 9 months' time.
Thank you for joining us today. Thank you, Harry, for being with us.
Thank you for having me, Jaq.
And thank you, Elliott, for doing the Secret Solve.
Yes, thank you, Jaq, and thank you, Harry, for writing such a wonderful case. I hope you enjoyed following along with this solve.
If you like big atria and you like it so on. I mean, that's a sales pitch if ever I heard one. But we will be taking the winner of the UK champion with us to Vegas.